As Director of the Climate Centre, I'm responsible for climate services for the state of Utah. Very much involved with research on the Intermountain West. We were taking our research and put it into an operational capacity in terms of prediction of certain climate phenomena. Climate, I think, transcends almost everything. What we're trying to do is to try and predict a seasonal type of forecast, which maybe goes out about a month or more. We found a connection between the sea surface temperatures in the Western Pacific and the rainfall seasonality in northern Utah. We've also been able to use that connection to forecast the elevation of the Great Salt Lake. But the fact you've got this high correlation between our research in the Great Salt Lake elevation and the water supply of the Colorado means that we essentially have a predictive tool that will aid water managers in the future. Utah is interesting that it actually has these two regimes, the northern regime and the southern regimes, which are actually driven by different climate drivers. One of our major initiatives in the Climate Centre has been the establishment of weather stations. We have over 120 now in the state of Utah. These weather stations are extremely important for the farmers, but they're also very important in measuring one aspect of the water budget, and that is evapotranspiration. We're getting more precipitation, but more is coming as rain. Utah's important water resource is actually the snowpack in the mountains. And how much snow we get there and how it melts in the spring season is what determines what goes into the ground and is therefore the main source of water for Utah. Climate prediction is actually very, very difficult because climate transcends the whole world.
Robert cannot be here today. My name is Simon Wang, but we work very closely within the Climate Center as well as the climate program at Utah State University. So allow me to show you a little bit of the short presentation here. My task today is really to give a very brief outlook of climate and projections, also to reach out to see what kind of information you will need in terms of short-term and long-term climate predictions. So it's quite important that we go through, look at the future by looking back just what happened so that you can know that how much and how well the models predict. You can see that for the past 3 months, from January to March, this is the model output produced by they call this a National Multi-Model Ensembles. So it consists of anything between 7 to 9 different models from NASA, US models, a few Canadian models, and then European models. So it's really what I call it 8-team models to produce so far the best predictions possible. You can see this is the precipitation prediction when they began probably in December last year, and then to see what the next 3 months will look like. So if you're familiar with the US precipitation change during El Nino, so that's on the right is the empirical analysis on what the El Nino precipitation looks like. So the models, all these models, 7 to 9 models, they dutifully produce something very similar to what the El Nino looks like. So you might know that we are still in the El Nino phase. However, this is why we think doing climate research, especially for these regions, is important. In the western US, you can see that the beautiful dipole structure in the observation, it didn't happen. It was opposite. It was really opposite of that. So it means that somehow in the western US, especially in the Intermountain West, it is not feasible that we use El Nino or ENSO in general to serve as a prediction tool, because you can get wrong, okay? And then it's why we try to understand by capturing other climate oscillations, anything from the better known Pacific decadal oscillation to a less known but important to our region, something we call quasi-decadal oscillations, and also the El Nino transition into La Nina, how those are between 4 to 5 years of cycle, what's the ocean situations, in the Western Pacific is transitioning into the next phase. They all have roles played in our system here. So this is a prediction that we try to do for the same January to March. We launched that in October last year. And this year we predict, you can see the red dot, that's roughly about normal range, okay? And that's in northern Utah. You can see from the color map, there's nothing there, no anomalies. It means that it's about the same amount of precipitation you will get during the normal 30 years period, okay? So how do we do that? We also try to integrate Great Salt Lake informations, because Great Salt Lake itself, as you know, it's a big integrator of all this hydrological and weather forcing here. And I want to show you a short video here just to tell you how this is done. In 2009, we already tried to publish an 8 years prediction of the Great Salt Lake elevation. And this is important, I think, for now, because we are in 2015 now. So we already have the entire 8 years of data to do a verification. So green is the prediction, and now we have the blue. So back then you could see this transition up and down. And we thought that it's very important because for the Colorado River water supply, you might know this figure here. You can see that the water supply is very coherent with the Great Salt Lake elevation. So because we kind of could produce that, we try to forecast all those. We can probably use this information to forecast the water supply as well. And this is important because it's climate signal. So it's kind of irrelevant of how the diversion would take place, because the climate cycles up and down. They're very cyclical, and that provides us a natural tool to use for prediction. So this is the very current prediction we posted on the Climate Center. It basically shows you that the water level coming down for another year and then come up. What it means behind all this water level change is that we might start a wet phase for the next 2 to 3 years with a higher than normal precipitation. We hope that is the case. Now, looking back, this is December last year. Precipitation, you can see the green is higher than normal. So northern Utah, well, February didn't get too much. And March, we still have higher than normal rainfall. Well, not southern Utah, of course, but in northern Utah, that's the case. April, up to this point, the first half still. So you can see that we actually have near normal or slightly above normal precip. But why snowpack is below normal? And that is consistent with something we worry a little bit, because you can see that the transition season temperature has been rising. And you might know that February was the hottest on record, the global temperature-wise. And just people were starting talking about that. March shattered that record by, you can see, that is the March temperature, 2016, and that's February. So it's setting records. And this is becoming a very accelerate tendency, especially for the polar regions here, because this year, January and February of the polar region temperature also set the record. The sea ice cover was the thinnest ever recorded from NASA and also from NOAA and European agencies. And that we started to wonder how this would do to so-called seasonal or sub-seasonal variability, because you know that the warm spell that can last a week or two, they are strongly tied to what we call the sub-seasonal variability here. This is one graph. This is a nice graph produced by the National Geographic. Provides you how this Arctic forcing and then the sea ice melt and then the interaction there can change the jet stream and sometimes give you this super strong ridge or super deep trough that produce severe weather. And we try to capture this variability. It's quite challenging, but we also try to continue to monitor tropical inference here because this is something that strongly influence weather patterns here in the western U.S. here. So just give you one example. Very soon, the Climate Center meteorologist Martin is going to defend, and this is a busy layout, but you can see that this is something he put on as his master thesis here. He will defend next week. And through something like this, we capture the jet stream meandering system, the pattern there, and also the proper time scale from about 2 weeks to a month. And we hope this can especially provide some useful information, in particular to the snow melt season, because as you all know, April, May is very critical seasons. A 2 weeks very warm spell can really trigger a lot of snow melt here. So this is what our April to mid-May projection looks like, 1 month out. Dry condition prevails, 30% below it means precipitation. Warmer than normal and 40% warmer compared to precipitation. This is very abstract. And of course, different regions, by spending some time, you can start to get more deterministic numbers. But this is just a very short outlook here. And what it means is that in the next months, we probably need to watch out for rapid snow melt events because the ridge is building, and calculating how much heat contained in those 1 week to 2 period of ridge events is critical. And we're trying to monitor that, but we want to reach out really to disseminate information in a way that you guys need it and can use it without too much of interpretation, and that takes a lot of communications. So I want to ask you, what kinds of information would you like in terms of climate prediction, point of view, because this is still quite new in terms of connection the data provider to data users. And I want to just share with you some examples I found particularly intriguing by the Australians. Their Bureau of Meteorology, they provide something like this, very well done. It's just 4 minutes long. I won't show them, but I will cut across that. So they will have something, I'll say probably their version of Brian McNary here, and provide information like this. So great visual and very clear explanation. Would that be something you prefer? For example, I'm just one example here, but that video that they make it every month or every other month. It's very effective, visually and intellectually. And so on behalf of Rob Gillis, I want to also send out an invitation. If you could find a time and come visit the Climate Center, and then we can have more conversation and about what kind of information you really need. That's all. Thank you.